All right, so I'm going to use the BMI data set from earlier in the semester that we used. We used 20 lines of these data, but I'm going to use the whole data set to show you how to run several one-sample t-tests. And in order to do that, you need to have a continuous or ratio variable. So let's look at our variables. We have number, which is just the ID number. We have gender, which is nominal. We have height, weight, and index, which is the BMI, and those are all scale numbers. And then we have race, ethnicity, which is nominal. So we're going to be looking at one sample t-test on these three variables: height, weight, and index. Let's go back to our data. Now in order, I can see that, you know, the BMI, it's 2, 3, 4, 5, 1, 2, 3, 4, 5. So I could test against 1 or 2 or 3 or 4, but let's just run a quick descriptives on these three continuous variables so that we can kind of get a ballpark to see what would be a good number to test against. So I'm going to go to descriptives. This isn't necessary. This is just to give me an idea of what's a good number to pick. So I'm not going to pick number because that's an ID number, but weight, height, and index. And I'm just going to, let's just look. Everything pops up over here. I'm just going to do just the mean. That's all I want. Okay. And so we see we have 500 lines of data, no missing data. Our height, the value is 169. The weight is 106. And the index is 375. So let's do a one sample t-test on height. Let's go Analyze, Compare Means. One sample t-test. You can see I have all the scale variables are listed, but I'm interested in height first. So let's click that over. So we have 169. Let's see if we're significantly different than 165. So let's put our test variable in as 165. We'll leave this estimate of effect sizes. Our options are just boilerplate and auto checked, and that's all we have to do. So we're just going to say OK. All right, so we get our one sample statistics. These are descriptive statistics that just describe that particular variable, that sample. So we already knew that we had 169.94. Our standard deviation is 16.375. And then we look at our t-test, and our test value was 165. Our t-value is 6.7, so that's pretty large for such a large sample size. So depending on our one-sided or two-sided, but we're always going to just default to two-sided unless, you know, a specific problem tells us to use a one-sided, we'll just use two-sided. But you can see in either case, they're both highly significant, way less than 0.05. The mean difference was 4.9. And then we'll talk more about this later, but these are the confidence intervals. And this is 95% confident that this mean difference is somewhere between 3.5 and 6.4. We'll talk about that more later. And then we can see that our point estimate for our Cohen's d is 0.3, so somewhere between small to a medium effect size. All right, so that's for the height. Let's do weight. So I can go to the automatic or the recall recently used dialogues. Let's toss back height, and then let's toss over weight. Now we have 106. Let's test against 108. Okay, so let's look at our sample statistics. We have 106. We already knew that it was 106 from the descriptives that we had run before. Our variation is a little bit more variable than it was for the height. We look and we see our t-test, our t-value is pretty close to the mean, 1.3. It's in less than 1.5 standard deviations away from the mean. So if we look at the one-sided p and the two-sided p, we can see that we are not significant. P is equal to 0.17, which is not less than 0.05. So p is not low. So the null must stay. The null does not go. And then our mean difference was 2, -2, because it took 106 minus 108, which is why we end up with these negative numbers. So it doesn't really matter if they're negative or positive. It's kind of the absolute value we're looking at. And then here we can see our point estimate was 0.06. If 0.2 is a small effect, this is practically no effect. So that one was not significant. Let's run that one again and test it against 100. And I picked 100 because it was 106, so now 100, and now we have a t-value of 4.1. And we have a highly significant p-value. Our mean difference is 6. And now we have still a small effect size, 0.19, which is almost 0.20. Okay, so that one was significant. Now let's look at the BMI. Let's go back to the one sample t-test. We're going to toss back the weight. We're going to put in index. I do believe it was 3.5. So let's test against 4.5. All right, so, oh no, the mean was 3.75, so we're testing against 4.5. We have a very large t statistic, and we have highly significant p-value. Our mean difference is not that large, but it was highly significant, and just FYI, the bigger your sample size, the better the chance you have of finding significance, which is why we use these Cohen's d's, because you could manipulate things by just increasing your sample size. If you're close to not significant and to significant, you just want to throw in more data, you have a better chance of finding significance. But this is a way to kind of reel that back in. So we have a 0.56, which is a medium effect, which is nothing to sneeze at. All right, so that's how you do one sample t-tests.